All right. So the next one I want to look at is what is called the goodness of fit test, which is a bizarre kind of a name in a lot of respects. Um, goodness of fit test. What on earth does that mean? And the idea of it, goodness of fit test, is we again always have some assumption going in. Okay, and so it may be that you think that tulips are, I don't know, 20% white, 20% yellow, 40% purple. By the way, that puts us up to 80%, right? 10% red, that's 90%, and 10%, I don't know, pink, I guess, whatever. And that's what your model is. I mean, that's what you believe that's true. Okay, whatever. So, whatever. So I go out and I actually find some tulips, and I count them, and I find oh, I don't know, 39 white ones. Actually, I'm going to write white on the other side. I'm going to set this up a little different here so that hopefully when we're done, you're like, oh my gosh, that makes so much sense, Jay. Hey, thanks. That's what I was trying for. So the white ones are right here. And I'm going to go out and I'm going to find, in the same patch, I count 46 yellows. And, I count about 75 purple. And about 21 red. Now, if you'll allow me to count for a second quietly. 19 pinks. For, if I'm not mistaken, a grand total of 200 tulips. Okay? This is what I observed. This is what happened. I went out and I counted. I saw them with my own eyeballs. And I saw them and I said, oh yeah, that's how many there are. I kept track of them. But wait a minute. I expected 40 white. How did you know that, Jay? Well, there was 200 total tulips, yes? And I was expecting 20% of them to be white. 20% of 200 is 40. I also expected 40 yellow. By the way, I'm not shocked that I got 39. That's a little weird, but not horrible. Hey, what is 40% of 160, 200? It turns out it's 80. So again, this is a little different, but not horrible. 10% would be 20, and 10% would be 20. Nice. Again, for a total of 200. Okay. And so this next test really is pretty straightforward, because the goodness of fit test says, well, how far off are you from your observes from your expected values? That's really what it's all about. And this test is a chi-square test. And it is the sum of the observed minus the expected squared divided by the expected. Which that sounds hard. It's literally not. So we're just going to take 39 minus 40, square it, and then divide by 40. And then 46 minus 40 squared, divide by 40. And so on and so on and so on. And then add up that numbers when I'm done. Now, I refuse to teach this any other way but with Excel. I just refuse to do it anymore. There is absolutely no reason to just not do it in Excel. People that say, well, I'm not very good at Excel. I'm sorry. No. I still drive a flip phone, for crying out loud, so if I can run this kind of technology, oh my goodness, you can too. It is just the way to go. Wow. All right. Boom. Boom. Done. All right. So let's do it. So the formula says, let's find the observes minus the expecteds squared divided by the expecteds. Ta-da! Now, you'll notice that this time I put the observes in column A. I could just as easily put them in column B. So just make sure who you're subtracting from whom and who you're dividing by. And make sure you're doing observed minus expected squared divided by expected. Now, if you do that, click on the corner right here. See your cursor looks like that. Now it looks like this black one. Click on that and drag it down. And then we're simply going to add up this column. So you can click on auto sum right here, for instance. And that's my chi-square value. So my chi-square value over here is 1.3375 or whatever it was. Okay. Well, wait a minute. Chi-square always has a degree of freedom, and you're right. It is k minus 1. That is, there's 1, 2, 3, 4, 5 groups, so it's going to be 4 degrees of freedom. Okay? Now, this test will always be the same. It is H naught. The model is a good fit. What model? The assumption was it was 20, 20, 40, 10, 10 percentage-wise, right? Is a good fit. In other words, it describes what's actually happening in the real world. And of course, it's a poor model. It's a lousy model. It's a terrible model. It doesn't describe reality. You could phrase it about 100 zillion different ways. Okay, it's just not very difficult to do. That is what you're going to be testing when you're doing these guys. Okay. Now this chi-square test is an upper-tailed only test. Okay, it's an upper-tail only test. So we're going to just do an inverse chi-square. So equals chi-square inverse. Now 0.95, because the computer wants the area to the left. That puts 0.05 in the upper tail. 4 degrees of freedom. So again, the picture's here. So 9.4 or whatever. Notice where we are. We are down in here. What does that say to us? It says that we're going to fail to reject, and what does that mean? That's a pretty good model. Fail to reject H naught. The model is a good model. It's a good fit. What does that mean? It just means it's really describing what is actually happening in the real world. Okay? Now, if you want a p-value for that, I mean, we're already in Excel for crying out loud, so let's just do it this way. Chi-square dist, right? So we're going to go from here. We have 4 degrees of freedom, and it's cumulative. And because this is an upper-tailed test, we're going to make sure we do 1 minus that. So you get a 0.85. That's our p-value. Well, Jay, that literally happens every day. I know, right? So if our p-value was 0.05, our alpha was 0.05, man, we're way bigger than that. So again, we fail to reject. Okay? Now, let's do another one here. And let's pretend that I know anything about Skittles. I'm not a big fan of Skittles. I think you might as well just go to this cupboard and eat sugar, but whatever. Let's just say that there are 7 colors of Skittles. I honestly don't know, and I honestly don't care. But there it is. And I believe that they are evenly distributed. Or another way of saying that is, I believe that their percentages are all the same. They're all the same. I still can't believe I can read my handwriting. Alright, so in other words, it's 1/7, which is approximately 14.2%, right? Of each of them. Right? And so, when I do this, if I went out and I counted up some Skittles, and I kept track. And so when I kept track, I found I got 30 of these, and I got I need 2 more colors. Orange, Pink. Sure. By the way, you can put pink at the bottom. It's not important where it goes. Okay? Now, I can't have a calculator here, so it's 60, it's 87, 107, 152, 182, 222. I have 222 Skittles here. Does that make sense? That's just what it is, right? 222 Skittles total. Now, of them, I would expect them to be evenly distributed. So, what I'm going to do is I'm going to come in here and I'm going to write down, hey, my observes. And I'm probably just going to have the calculator add it up because I don't really trust myself always. There are some days when I'm a magician when it comes to adding and stuff, and there are other days when, wow, did I really just say that? And so if you do that, the sum, yep, it is 222. Good for me. The expected values, and here I'm just going to say equals, it's 222 divided by 7, right? I mean, I expect this many. Well, gee, you can't get 31.714 red Skittles. No, that's what I'm expecting to get. You also can't have 2.2 children per family, and you also can't have 1.7 dogs, and yet that may be the national average. That's what you'd expect. You'll never get that, okay? And so when I do this, again, the formula is so straightforward. It is literally equals parentheses, observed minus expected, squared, divide by expected. That's it. Click and paste that down. Hey, let's add those up. Holy cow, I get a chi-square of 38? That's huge. That's huge. And in my mind, what am I thinking? Well, I'm probably going to reject H naught. My H naught is that the colors are evenly distributed. I don't think that's true. How about you? And so H1, of course, is it's a poor model. And so I get a chi-square, what did I say, of 38? I think 38.2. I'm just going to go find a p-value for that. So I'm going to do 1 minus, because it's always an upper tail, chi-square dist, like so, 38. Degrees of freedom at 7 different colors, so 6 degrees of freedom, and then 1. 9.9 e minus 7. That's 0.0000009. Okay? That is way less than our alpha, which I didn't even mention it. So, wow. We are rejecting H naught. And what are we saying? This is a terrible model. Reject H naught. This is a horrible model. People I work with have in the past have gone on and just talked about they used to be able to get the actual percentage of colors of M&Ms back in the day. I just don't care that much. But you know, whatever, you make stuff up as you go along. Okay. Yeah, I don't know. So yeah, on the so Pete. Let's say Pete thinks 30% of bus riders are white collar types. 60% blue collar. 10% other. Okay, whatever. So that's what he thinks. So that's basically your model right there. In essence, that is your model. 30% white collar, 60% blue collar, 10% other. That can be your model. And so then H1 is, of course, that's a poor model. Let's just do alpha's 0.05, because why not? And so, you know, here we go. So we go out and we watch one day and we find that there's 15 white collars, and blue collars there's 90, and others there are 22, for a grand total of, that's 127 peoples. That's cool. Now 127 times 30%. That's what I would expect, yes? And so, let me just, maybe. So my observes are 15, 90, and 22. And again, I just like to sum it up. I don't always trust myself, so boom. And then my expected values are equals, and you can just do 127 because that's how many there are, and you'd expect it to be, oops, times 30%. So you're expecting 38, you got 15. That's really weird, dude. Equals 60% times this 127 business. And then equals this guy times 10, right? That's what I was expecting. That's what I got. These all numbers are strange. Guess what? I'm probably going to reject H naught because it's a weird thing that I saw. So observe minus expected. Divide by expected. Sum those babies up and you get 23 for my chi-square. That's ridiculous. So over here, I'm going to go equals. Again, it's a upper tail test, so I want to make sure I do 1 minus. And so 23. Degrees of freedom, there were 3 groups, so 2 degrees of freedom, and then 1. So 8.5 e minus 6, so 0.00008. So clearly I'm rejecting H naught. And again, by rejecting H naught, what am I saying? It's a lousy model. And now what am I going to do with that? Why does this guy want to study that? Well, if in fact more blue-collar people ride the bus, you know, I can then advertise to different kind of people, right? Because, you know, quote-unquote blue-collar people would have different characteristics in terms of what they want to buy, right? So I could target advertising differently. I might, if they're, you know, white collar, if they're like way more white collar people, I might be more interested in, you know, things that may have to do with, you know, business oriented things. Like, for instance, like fold out tables where a guy could sit there, a person could sit there with their laptop and do some work and maybe have some Wi-Fi connectivity or what have you. In other words, I might want to cater to people differently based on what kind of people I have on the bus. Okay. And again, these are the things that actually, when the rubber hits the road on this deal, you could sit there all day long like the tulips. Who cares? Nobody cares. How they're distributed. At least I don't. Same with my Skittles. I don't eat Skittles, but if I did, I just wouldn't care. But when it comes to things like this, you're like, well, I was under the impression I had this many white collar, but I actually have a lot less white collar and maybe a lot more blue collar people. Maybe then having people advertise, let's say, suits or something on my bus is a goofy thing to do. But it may be Dickies work pants or some such. You know what I mean? Something that's more tailored to the people who ride the bus. Okay? And I gotta say, being as more of a blue-collar dude, more like a blue-collar dude out of water, you know, I would understand that, where, you know, you look at that and go, why are you advertising that to me? I'm not in the slightest interested in that situation there. Okay? Again, here is a situation that... Ooh, excuse me. I'm gonna die. Alright. So, I don't know. Someone's got a huge hog herd or something. I don't know. And he thinks that he has 2 parts Duroc to 3 parts Hampshire to 3 parts Yorkshire to 1 part land race to 1 part spotted. Now you're like, I don't even know what that means, Jay. It's not important. These are just different pig types, that's all. But what does this mean? 2 to 3 to 3 to 1 to 1. I'll tell you what it means. What it means, it would be nice if Jay could add, is what it really would mean. That's 5, 8, 10. No, that's right, we're good. What it means is that his pigs are broken down in a 2 to 3 to 3 to 1 to 1 relationship. In other words, 2 out of 10 of them are the Duroc type. And 3 out of 10 of them are the Hampshire type. And 3 out of 10 are Yorkshires, and 1 out of 10 are Landrace, and so forth and whatnot. In other words, that's his idea. And of course, as always, this is a poor model, or a lousy model, or it doesn't fit reality. Okay? And again, whatever. Maybe, actually, I was reading about some wild hogs today. Maybe you want to trace their lineage, where, we think that their lineage is something like, 2/10, if you will, or 2 parts Duroc, 3 parts Hampshire, and so on and so on. So it could be anything like that. And so if you go out there and collect them, and you say, all right, well, here's the Durocs, and these are my observed values. 20, and my Hampshires are 25, and my Yorkshires are 25, and my land races are 15, and my spots are 10. Okay, and you're like, well, let's add that up. Well, it's 50, 100, 115. No, is that right? What am I doing? 50, 65. Wait, 50, 65. Right? 75, 95. Okay? And again, I don't trust myself, so I'm just going to open a tab and do it on Excel. So my observes are as follows. Again, 20, 25, 25, 15, and 10. Then my expecteds are as follows. Now, let's go ahead and get a sum down here because that just makes our lives easier. It is 95. So I was expecting 2/10, right? Because again, there are 10 parts. 1 plus 1 plus 3 plus 3 plus 2 is 10 parts. 2 of them, or 20%, should be the Durocs. Oops, and I didn't hit equals. What an idiot. Yeah, apparently I did. I just didn't hit times. There we go. Boom. Done. So then equals 0.3 times 95. So that's the exact same answer here then, right? And then, oh, I was like freaking out. What happened, man? The bottom one is a sum. It doesn't count. And the 95, so 9.5. And so here I'm going to say equals, and again, if you're paying attention at home, that minus that is hardly any difference at all. So I would not, so that actually looks like it should be right. This minus this and this minus this are, yeah, there's some difference there, but not a ton. Quite a bit of difference, not much difference. So it would be possible that we don't reject H naught here. We fail to reject. So we get 4.12. So here again we go. It's going to be 1 minus chi-square dist. This guy, comma, degrees of freedom. There are 5 different hog types, so 4, and then 1. So we have a third, that's our p-value. Our p-value is 0.389. So our decision is to fail to reject. And by failing to reject, we're saying that's a great model, or it's a good model. Fail to reject. H naught. This is a good model. That is, it really describes what's going on in the real world or in nature or whatever. Okay, it's a good fit. Okay, so there we go.